Okay, so it's rise and run concept. So I'm having to pause and fast forward this several times. So if I wanted to calculate the slope and I didn't know these 2 points, okay, we can use rise over run to kind of calculate and determine what the slope is. And so in this case, I can start at any one of these points. If I start here and I go my rise, I'm going in the positive 2 direction. I'm going up 2, so it'd be a positive 2. So rise over run, my rise would be 2. My run would be from this point here over, and that is 1, 2, 3, 4 units. Okay, and so 4 would be over here. Now, one of the things I do want to do, okay, 2 over 4, we can reduce that. So we probably could have chosen some smaller points in between, but my slope would be positive 1/2. And we'll talk about positive and negative slopes here in a minute, but that's just to give you an example of the rise over run. I could have done the same thing in this direction. If I started at this point, I could have gone down 2 negative and left 4. Okay, so negative 2 over negative 4, I still would have gotten a positive 1/2. Okay, and then just to give you a non-example of what slope isn't, okay, we can really only use slope for straight lines. Or what we call linear lines. Okay, and so if I have a coordinate plane, I cannot use slope for graphs that look like this. This is called a parabola. This would be a quadratic, or even something that looks like that. Those would not be examples that I could use slope and calculate slope from. So hopefully this gives you kind of an idea of what we're going to be doing with slope. There's going to be several different methods that we use. We're going to go through those in the next several pages. But slope, remember, it's the ratio of the vertical change to horizontal, rise over run. Now, on this next page, okay, finding slope from 2 points, this is going to go in your interactive journal on page 16. It's going to be its own page. Okay. And so you need to memorize this formula. I will not give that to you. And every year I have students flip-flop these. Okay, now finding a slope from 2 points. On this type of example, to use the slope formula, you have to have 2 points. And you can see that this is clearly labeled. Whenever we look at our coordinate pair, the x comes first, then the y, x, and then the y. This subscript here is just labeling that this is the first coordinate pair, this is the second coordinate pair. So if you look down here at your formula, m, okay, is the symbol we use for slope. Okay, so if you see a problem that says m equals a number, then that's telling you what the slope is. Okay, in the formula, this is my vertical change. So the difference between my 2 y values, y2 will go first minus y1, and then you got to watch your negatives in these. This bottom expression is my horizontal change. Okay, how does my x numbers differ? And yes, x2 minus x1, watch your negatives again. And we'll plug these values in and you can kind of see. Now what I like to do is kind of color code these. So x1, x1. I'm going to use lots of colors on this page. y1, you can kind of see the values when your coordinate pair are going to fit directly in to this formula. x2, x2, you can see that goes on the bottom. And then last but not least, y2, 2. Okay? Now remember, borrow that. Now, a couple of things that students miss every year is what happens if you have 0 on the numerator or the denominator. Okay? And so, if the 0 is in the numerator, your slope is equal to 0. Okay? And one way to remember that is it's okay if the 0 is in the numerator. Okay, we're going to have 0. O is on the top, 0 is okay. What if 0 is on the denominator? Then your slope is undefined. Okay, and one way to remember that is no. Okay, no would be undefined. So try to use those little tricks to remember, because if you get 0 on the bottom, you can stop the problem. Your slope is undefined. If 0 is on the top, your slope is 0.